Hello everyone. So let's solve today's LeetCode POTD. Find all people with secret. So the problem states that we are given an integer n, which indicates the number of people that we have, and the people are numbered from 0 to n minus 1. Now we are also given a 0 index 2D integer array meetings, where meetings of I will denote the people involved and the time at which the meeting is happening. So x and y person have a meeting at this particular time. Now a person may attend multiple meetings at the same time. This is also given, means at a particular time t, this xi can be present in multiple meetings. And we're also given an integer first person. Now person 0 has a secret, and initially he shares the secret with person this first person, okay, at time 0. Now this secret is then shared every time a meeting takes place. Suppose now initially 0 and first person knows the secret. Now if first person has a meeting with someone, suppose second person, then that second person will also be able to know the secret in that particular time. Okay, more fully, for every meeting, if a person xi has the secret at time ti, then they will be able to share the secret with person yi, and vice versa as well. If yi has a secret, then we'll be able to share it with xi. Now also we are sure that the secrets are shared instantaneously, because a person can attend multiple meetings at a time. So suppose we share the secret from xi to yi, and then yi has a meeting with zi at the same time. So yi will be able to share the secret with zi at the same time. Okay, so a person may receive the secret and share it with other people in other meetings within the same time frame. Okay, for example here yi, he received from xi and then shared it with zi at the same time. Now in the end we need to return a list of all the people that have the secret after all the meetings have been completed, and we can simply return the answer in any order. So what is like for example, if we have this as a given input, so initially the first person is 1, so the known set will be initially including 0 and 1, right? 0 and 1 are already known the secret. Now and the earliest time that we have here is 5. So at time 5, since this person 1 knows the secret, so he will be able to tell person 2 the secret. So this set will become now include 2 as well. Okay, so now these many people know the secret. Now let's time passes and we reach time 8. At time 8 we have the meeting between person 2 and person 3. So this person 2 will be telling the secret to person 3. So now person 3 also knows the secret. Okay, and then we move on to time 10. We see like this person 1 knows the secret, so you will be able to tell person 5 the secret. So hence the person 5 will also know the secret, and all the meetings have been now completed. So this is the set of people who know the secrets. So we'll simply return the set of 0 1 2 3 5. Okay, similarly let's see another input. So we are given n equals to 4. So initially persons who know secret are 0 and first person is equals to 3. Okay, now the first time that we occur a meeting at time 2, so no means neither person 1 neither person 2 knows the secret, so no one be able to share the secret. Okay, let's now move on to time 3. So at time 3 we see like 0 and 3 knows the secret. Okay, so here 3 knows the secret, so 3 will be able to tell 1, and since 0 and 3 already know, so they will not be sharing. Okay, so only 1 will able to get to know about the secret, so 1 will be able to get it. And now all the meetings have been completed, so the people who know the secrets are 0 1 and 3. So we simply return this set, and we can return it in any order. We do not need to return in this specific manner. Okay, so like what does the problem ask us to say? Like let's see the generalized problem statement. So we let S be the set of people who know the secret initially. So initially at t equals to 0, what do we this S will having? S will be having 0 and first person, right? 0 and the first person that we get. Now if a meeting is a tuple x comma y comma t, then if a meeting occurs between x and y at time t, so what will happen? If this x belongs to this set, then this y will also be added to this set. Or if this y belongs to this set, then this x is added to the set. Okay, so if either of them is present, then the another one will be added to this set. Okay, now we also given that a particular time means a person can receive and then share the secret with others as well. So if we have 3 meetings at time t, suppose a, b, b, c and c, d, and only a knows the secret initially, so at time t only a will be telling b, then b will be telling c, and then c will tells d. Okay, so a tells b, since this happens at the same instant, b immediately tells c and c tells d. Okay, so at the same time all 4 of them will be able to know the secret just from a only. Okay, so like what can we like do here? So we can means get an intuition that since we are given like the meetings in the form of pairs. So maybe we can construct a graph because we need to find out at a particular time how many people are connected with each other, right? Because if we find out the number of connection, means the people who are connected with each other at particular time t, then if one of them knows the secret, we can simply like means start a BFS from that particular people and move out till we are able to reach new people who do not know the secret, and simply keep adding them to our known set. Okay, so maybe if we are able to get the connected set of people at each particular time, then we'll be able to means solve this problem. So let's try to create a graph. So how we'll be creating a graph? So graph will be simply, the nodes will be the people involved in meeting and meeting at particular time t. So we'll be creating a graph at each time. At each time t, at each unique time t, what we'll do, we'll create a graph. Now when we create a graph, we'll be able to know that at this particular time, these are the people who are connected with each other. Okay, these are the people who are connected with each other. Now once we have this graph built, what we'll do, we'll simply means start a BFS, and in the BFS we'll know, like suppose this person knows the secret, so we'll push him. Okay, we'll push this person in the BFS. Now we'll call the BFS. So in the BFS call, in the first step, it will be propagated to this, so these two will know the secret, and in the next step this will also know the secret. Okay, so hence we'll simply start the BFS, means we can start a multi-source BFS from all the people who already know the secret, and then we can propagate it forward using like the normal BFS in the graph that we have constructed. Okay, so in this manner, we'll ET contains an undirected edge between UV for every meeting UVT. Now what you'll do, like a person P belongs to this VT, learns the secret at time T if and only if there exists a path. Okay, a person P will be able to learn it if there exists a path between P and Q where Q belongs to the known set. Okay, so since there existed a path between these two nodes, that's why since this person knew the means secret initially, this person was also able to know because there exists a path between these two values. Okay, so we can simply find out whether there exists a path using simple BFS, simple multi-source BFS from the nodes who already know the secret. Okay, so what is the algorithm? The algorithm is to simply first we need the means nodes to process in the order of increasing time. Okay, so we'll sort meetings increasing time. Okay, increasing time. Now once we have sorted it on the basis of increasing time, now we'll see if we have a current time t, what are the meetings that will happen at this particular time. Okay, so we'll identify all those meetings ui vi, then till uj vj suppose. Okay, so these are the meetings between people that are happening at this particular time t. So we'll construct a graph between all these means people that we are given. Now once we have constructed the graph, what we'll do, we'll initialize a BFS. So it will be simple BFS in which we'll push all those people who are already known. So initially upon our known value, we'll create a known array which will be initially false. Okay, and now at time 0 it will be true for means known 0 and known of first person. Okay, first person is equals to true, right? Because initially these two person only know the secret. Now we simply initialize the queue and means traverse through all the nodes which are present at this particular time. So we also need to know what people are present at this particular time. So we'll use a set to store these people, and then we'll simply iterate through the set to identify those people for whom this known value is true. And if it is true, then we'll simply push it in our queue. Okay, then we'll simply start the BFS, we will start the BFS while negation queue.empty, and at each step what we'll do, we'll iterate through the graph for the given node. So current node, if it is u, so iterate for int v adj of u, and we'll see if means we'll simply push this v in our true and make known of v as true as well. Okay, so this is what we'll do, and in the end we'll simply iterate through from 0 to n minus 1 and see for all those values whose known is true, we'll simply return it in our result. Okay, so this is the approach for this problem. We simply try to do what the problem was asking us to do. For each time we try to build a graph and then try to propagate the secret from one people to another people using normal BFS. and using normal BFS we are able to propagate it and then update this known vector so that we do not push it again and again. So this is the overall approach for this problem. Let's try to see the code as well, then it will become much clearer. So the first step is to sort the meetings on the basis of means meeting time. So we'll be sorting it on the basis of meeting time because time is stored in a of t, a of means the a of 2 index. Okay, now we initialize this known vector which will be like known of I is true if person I possesses the secret. So initially all the values are false and only person 0 and first person knows the secret. So hence the value of them will be true here. Now we need to process each means process the people by increasing order of time, and at a particular time we need to know what people have the meetings, then we'll create a graph on the basis of that meeting. Okay, so now we need to go meetings wise. So initialize this I with 0. We'll go till means we have not exhausted all the meetings. Now the current time that we have is meetings of I2. So we need to find out all the means this j will be moving till j till this means the time remains the same only. Okay, so we'll move this j, we'll be able to find the range I to j such that all meetings are contained between I to j at current time. So well means till this meetings of j comma 2 is equals to this current time, we'll be able to increase the j. So now from all the meetings from I till j, okay, I closed and j open, all the meetings between this will be corresponding to the current time. Okay, so now we can create a graph as well as find out the present people. So we'll be using an order map to create this graph, and then we'll be adding this present people to identify the set of people who are present in this at this particular time. So we are able to push it into queue based on like simply iterating through this and seeing whether none of them is true or not. Okay, so we'll move from I to j minus 1 with the persons that we have. We'll simply create a graph and also insert it in our present people. Now we initialize the queue for the BFS, we iterate to the present people, and if the known of person is true, we'll simply push it in this queue. So this will be simple a multi-source BFS. Now we'll start the BFS. So the current node that we have is q. We'll iterate through its graph, its neighbors, and if like known of a neighbor is not already true, we'll make it true and push it in our queue. So that too we can means if this was the neighbor, this was a neighbor, and this was not already true, so we'll push it so that we can process further values as well. We can make them true as well in like further iterations. Okay, so in the end, and now we'll update our I with this j value because j now points to the means the start of the next time. Okay, the first meeting which occurs as the next time. So we'll update our I with j. Okay, now in the end, what do we need to do? This known set, this known vector will be storing all means it will be storing true for all those persons who now know the secret. So we'll simply extract them. So we'll create this vector result. Now we'll iterate from 0 to n minus 1 and we'll see like if known of k is true, we'll simply push it in our result and finally return the result. Okay, so this is the overall approach for this problem. Let's try to see the time complexity here. So sorting will take like a big of m log m. Then we have this n vector, so it will be taking a big of n. Then we have this graph, so this will be taking will be going till big of m, and now this overall I, this will be going till m, and the total number of times we will be doing this k of I to j, this will be means overall it will be big of m. Okay, so this will be separately means it will be not be m into m because means this j will be changing and I will be changing as well. So in an overall fashion we'll be covering the entire range from 0 to m. Okay, so hence overall this will work for a big of m, as well as again this BFS also will in an overall fashion it will be moving big of m, means in an overall fashion it will be traversing all the edges. So all the edges it will traverse, that means it will be traverse all the meetings. Okay, so again in an overall fashion this will be occurring big of m. So hence the overall complexity of this means this entire processing is simply big of m, and the sorting part took big of m log n and m log m, and this took big of n. Okay, so the overall complexity is simply big of n plus m log n. Okay, now let's see the constraints as well here. So we saw like n can go up to 1e5 as well as m can go up to 1e5. So hence m log m is like pretty accepted here because means it will be of the order of 1e6 or like 1e7, and this will get accepted. So this was the like the pretty simple approach to solve this problem. We tried to like simulate what the problem was asking us to do. It simply asked us to propagate the secret at each time. So we, instead of creating means the entire graph initially only, at each time we try to created a separate graph, and then on the basis of that graph we try to propagate the secret at that particular time, so that we are able to like means separate the constants at a given time, and like this will be like a very small sub problem to solve. So yeah, this was the overall approach for this problem. Let's try to submit the code as well. This is the same code that we discussed. Let's try to submit it and see how much time it takes to run. As you can see, like it runs in 68 ms, which is pretty fine because of the sorting and everything. So yeah, this is like the overall approach, and if you were able to follow along with the approaches, make sure to like as well as subscribe. And if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.